Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're in here at the X-Carve in the fun room, and we're getting ready to adapt a engraving laser to the X-Carve. Now, straight up front here, I want to let you know that Op Lasers has given me the PLH 3D 6W engraving laser, the docking station, and a few accessories to have in my videos, give a review, and experience. They contacted me over a month ago, and this has been in the works. Anyhow, straight up front, that's what's going on. I'm excited about putting something in there. Who wouldn't want to play with an engraving laser? I've got a pneumatic graver. I've got a router graver. And now I'm going to have experience with a laser engraving application, and to experience lasers itself. All right, I have gone ahead and printed off simple instructions to get the laser hooked up onto the machine the quickest. Now, I'm still going to do the modifications of adapting my new router head and everything else to it. But I'm going to go ahead and make a quick mounting bracket. We'll be able to put the laser head right in the Inventables mount for their router spindle. And we're going to do some electrical hookups, and we're going to get this thing working right off. We're going through. We got the bill of materials here, and we've got everything on hand now, and we got the power supply for it, the shroud or the guard, the laser attachment, and the eliminator, and so that's in the bill of materials here. One of the first things is to go ahead and make a collar mount that goes around the square of the laser head right here, and it'll slip right down into the housing there. And they actually give me the Inventables G-code layout, and I've got it set up in my easel program right now, and I'm getting ready to cut it. Now, instead of cutting it out of wood, I've been really enjoying cutting and playing with plastics, and I've got Delrin in here. I've got a 1/8 inch end mill in there, single flute. Delrin and the ABS are pretty close on the speed rates and so on. Of course, I'm just running a vacuum. I'm not running water coolant or anything else like that, so I'm not getting too technical about it. I just wanted to kind of know the basic settings that I could go ahead and cut this Delrin. So I'm gonna try this out. This is 1016 millimeters a minute. Plunge rate is 304.8 millimeters a minute, and depth for pass 1.3 millimeters. It says that it'll cut this thing out in about 5 minutes. So we're gonna kind of play with that. Just got done with dinner, and Vanessa made yeah, that's maple syrup. A little sticky in there. I don't have a problem getting it burnt or caught in something, but I do get food on it. So, but maple syrup, that's not bad. All right. Oh, here's one thing I noticed too, because this instructions came with the laser, the paperwork here, and it gives me the wire diagram. But I printed this off on my printer, so I just noticed that that's the difference of metric and American paper right there. So metric paper is about 1/4 inch narrower and about 5/8 of an inch taller. So I don't know. It's closer to HD, right? All right, I'm going to put away this so that I don't get chips on here. I do have to check on my vacuum system, and I think I am just about ready to carve here. I've confirmed the material thickness, 1/2 inch or 13 millimeters. and it's secured down, and I'm 1/8 inch on the bit. And all right, now I can move this thing around, and I need to bring it back down this way here. All right, let me move this stuff up here. We're going to get the camera in here a little closer so you can actually see this thing work or crash, whatever it's going to do. This is a piece that I've been cutting all my wipers out of, and I haven't actually ran this thing in, oh, it's probably been a couple months. Let's see what happens. Okay, I've just confirmed 0 point, and I touched off with the paper. I do have a probe, but I haven't got it set up or got program friendly with it yet. All right, next step is to go ahead and raise the bit. All right, and now it's asking me, is the spindle on? Spindle's on. I've got to turn my vacuum system on. Vacuum is on. Okay, I can feel the draft. Spindle's on. All right, here we go. Carve. I got it set for a 1mm tab, 4 points on the bore, and 1mm 4 tabs on the ring on the outside. So the part should stay put, and the inside should stay put for the entire part. little tight on that one clamp. All right. We can probably pop that out of there, but if we can just snip those on the back side, it'd be a lot better. After grabbing this 1/2 inch, I remember I needed to get some longer screws there. I use this 1/8 inch plexiglass underneath for waster board all the time. Nice. That was the little tabs right there. So I'm gonna get my and that's nice clean. All right, I'm gonna go ahead and get my razor knife. Come back here and we'll snip those. Work the flashing off of here now. And a little tiny bit of chatter on there. You know, I probably could work on those speeds and feeds a little bit there, but we're going to see how this fits in there, and then we might just go ahead and take it on the Wilton, you know. Unless it's way off, then. Okay, let's clean off our mess here so that we can bring our laser head up here and check the fit on it. Okay, just at a glance I can tell that this is going to be too big to fit into the housing we have, because what we have is, and this is an early X-Carve, this is a trim router. Then they made a larger one there that also, I guess the DeWalt's 611 also fit in there. And we're going to go ahead and we're going to pull off our vacuum here, because we're in the overhead in a second. Okay, and we're going to go ahead and pull this out. We're going to pull our motor on out of here. We'll pull the bit and all of that. We'll pull this off of here. What we realized is we can go ahead and we can run this in our new clamp for our router that we're going to be running. But this is a little rough on the outside, and I want to dress this outside up, and our bore is about 10 thousandths tight on here, so I'm going to turn this around. We'll mount it into the Inventables piece here so we can keep it square. Then we're going to dress off our square in the mill with an 1/8 inch so we can keep everything perfectly square. Then we'll come back in here and we'll mount this up. Now we're going to go ahead and add 2 other rollers in here, because the height that we want the laser to be at is at that height right there. So we're going to go ahead and we're going to raise a 1/2 inch on these 2 lower rollers here, and the thing should still have all of the travel and be able to mount this, and we're not going backwards. Okay, when we left you last, we were going in to go ahead and turn this outside and dress up the inside so that we could fit this inside the holder here. And of course, it goes the front side this way here. This is loose. We aren't gonna we're not gonna have something that looks like this, because we had the trimming router which was smaller than the next size up. So this ring here is even bigger than that whole housing right there. So we went ahead and dismantled this. We went ahead and put our bracket on there to bolt on our adapter for the router that we're going to be using, but we're not going to put the router in here now. We're going to go ahead and we're going to put the laser directly in here. Alright, so what we did is we set this up, and the way that this has a notch out on the back side right here is perfect for this to set into, and we can put this all the way down so that it's perfectly flush, so that we will be setting up it at the exact height that it's calling out for in the instructions. So that's a press fit right onto there, and then we put this right down in here, and we're going to go ahead and take our scale right here, and we're just going to hold that right underneath there, and then we'll be able to adjust this square in there, and we can look at our gap back there where each side of that connection there is setting up there. Now we just got to go ahead and connect our leads as per the drawing, and that's the next step. And it's just basically color code. We put red to brown, black to green, white to yellow, and green to analog in. Alright. Okay, now this is just temporary because we are going to neaten it up, and alright, so we're going to go ahead and that looks just like the picture. Okay, now we're going to pull our slack through here. Alright, we're going to go tie in the other end. Okay, right now I just got a couple simple things here. This is an enclosure, and this power supply will be inside the enclosure here. And then whenever I want to run tests or check it or whatever, so I can see the light and all of that, and the hookup will be here, and the cords will go through and be set up in there. And the IoT relays are set up down here, and then they'll go into a power bus bar, which I haven't brought out here yet. So I am going to start setting up, and all my electrical is going to be on the side here, and it'll be in such a manner that nothing will be able to fall into any of the electrical outlets or whatever. We have an overhang here, and these are tucked up and underneath here as well, and the outlets are not facing up. Just kind of something in case I have some kind of chips or whatever. Mostly I'm going to be working with plastics, but alright, so I went ahead and took our leads. So we're going to be running the power here, and then this is going to go to the plug, which plugs into the back of the Inventables, which I move the camera when I get ready to plug that in there. So this is kind of simple, and this is just positive here, negative on that side there, and yeah, I think I already got these loose. And I need to be just a little bit low. Oh, I don't need to be. Working too hard here. Make it harder than it needs to be, right? Alright. I want it to be all nice and neat. The main thing is, after I get this running here, I'm going to be pulling these link belts and everything, or the cable carriers out, and I'm going to be shortening them up and neatening up all my leads on this thing. But with the two IoT relays here, alright, for right there for our test, and the other leads here will get screwed into this little bar here. The plug goes right there, actually turns over and goes that direction right there, just like that. All right, and spindle power and ground are the ones we're going to. Spindle power and ground. Second, third one in, and the fourth one in. And I need to loosen this up a little bit here. It's not like working with a 24-inch crescent wrench. All right, nice and snug. And reconfirming. And this is just loose right now because we're just testing this out. And all right, we are wired up. So the next thing will be to go ahead and give ourselves power to the power supply. And I think we have a few settings to set up on the easel. And so let's continue on our instructions here. It is recommended to use an additional nozzle while performing cuts with the laser head. The nozzle will direct the airstream much better in case where the laser head is positioned more than 50 millimeters from the material surface. Here's how the nozzle looks like, okay? And here's the nozzle here. Now it does have 4 screws, but it also has magnet, and it doesn't matter any 4 ways. As long as you're halfway square, it automatically will lock right onto it. All right, congratulations. Your X-Carve is now upgraded with a 3D engraving laser head. Before you can use it, however, you will have to set up your X-Carve first. In order for the laser head to work, the spindle PWM signal has to be enabled. There is a few ways to do that, but we will focus on the most user-friendly one and go to easel setup, blah blah blah, and here it is. And I will be going to that and then setting up the machine here. Okay, we're out here. We're playing out here tonight because we actually got our laser to laser. we got some burnt material on our board here, which is great. Friday we had Friday we pretty well had it all set ready to rock and roll, and then it got late on Friday, and then I needed some assistance from the tech crew there, and they were very helpful. And within just a couple communications back and forth today, I was able to experiment with some settings and basically telling the X controller what ratio to send signal to the laser for the intensity of it was the basic problem. But to find out and make sure and troubleshoot and make sure that the laser was flawless, we jump started, or we bypassed everything as far as brain thinking and gave it signal to fire on its own, and I was able to put 2 pinholes right in there within a second. We knew that the laser was working, so then we knew it was just a communication problem, and then I was able to get into that. And before I could grab my camera and get anything going here, because it caught me in surprise that it actually was working, we created op laser engraved right into the surface of the birch plywood here. I think is what it actually is that I have here. Okay, you can look down inside that O and P on op laser, and you can see how deep it actually grooves it out. And it, when you first look at it, you think that that's just burnt into the surface there. All right, pretty cool, huh? We're going to bring you in closer because I have another figurine here and I'm about ready to fire off. And this is like a bitmap picture that just happened to be in my G-code creator for the laser. And let me bring you in. Let's check it out. Okay, I don't have a pair of glasses for you yet, but this is what it'll look like when you're looking through my glasses. I gotta fix these so that they fit over my glasses, my eyeglasses, so I can still see. Okay, we confirmed homing. We're all clear here, and we should be okay. It's a raised bit. Turn on spindle. The spindle is on, and here we go. Okay, we're going to let that go through the program there, and we'll bring you back in and show you what we've actually done. Okay, I moved you in a different position, and I kind of played around with my lighting on my my new camera here, just kind of give you an idea. It's not so bright; it doesn't like blacken out everything. So you can see the little character that it's doing. It's almost finished. Still going up around the top of the character there. Alright, I moved it a little bit and brought them in a little bit of a focus there. I got the camera on a tripod and I just stepped on the floor. That's why it's shaking a little bit. But alright, there we go. Pretty cool stuff. That was just it was an already prepared little character that was in the program that creates the G-code for me, and we just can't wait. We can't wait to play with a few more things here, and also being able to get things drawn up with our Fusion 360 and other programs as well, and also. Let's get some other materials on here. I would like to see variable materials that I can laser engrave on, and including a piece of bronze or brass. I'd like to see what we can do. You know, we couldn't wait to get out here and play this morning. Yesterday we finally broke the barrier and found our communication problem, and most of the time that's what new things to new people happen when you go to set up a machine and you start playing with new software that you need to get adjusted to. You need to be able to put in all the parameters, but you need to learn what all the parameters are, and so I did. All right, now I just took another bitmap and burned it out. My Get Her Done pocket logo, and we're getting ready to burn another one here, and I'm going to move the camera over so that you can see it. And up here we have the Inventables up here, and this is what G-code programs look like on the Inventables format here. Okay, and this thing actually much faster than printing something or carving something. The laser is a pretty fast acting instrument, So I'm gonna go ahead and I'm gonna move this on over. We're gonna get set to carve this thing here. So let me get set up here, and I think let's increase that there. I think I'll put somewhere around there. Let's bring it on down this way here. Might as well put it up here in the front, right? All right. Let me check my height here. And we're at the right height. Okay, let me bring you in. There we go. Okay. Here we go. Now it cycles back and forth until it actually gets up to the part of the photo that it needs to start printing. Now I'm using a developing software that I was asked not to share with you at this point in time, and that's what I'm using to actually create what I'm able to do right now, and that is to create a G-code for the laser to actually print off what we are printing off. And if you can't see it yet, that is the Walk the Talk logo. This setting that I have it at right now is about half strength on the laser, and of course, it within the program of creating the bitmap, it also can change the intensity of the laser within its program there, so it gives you kind of the shadow or the fade in and out as well. It was more prevalent on Sonic there. My logos that I'm using right now they're pretty well defined lines there. Pretty cool. There we go. Now you can shut it off or run it back and let it run, and that takes you back to 0 point again. So if you had something clamped down and you wanted to continually do that same pattern on there, I could make a jig and I can make that repeat right there at the same size, same location, one right after another. That's pretty cool. All right, I've done a couple of their logos that they had in the program, and then I've added in a couple of my own, which is pretty neat to take my artwork, create a bitmap, feed the bitmap in, size it to what I need, create the G code, and then put it into the Inventables easel software, and tell this op laser where to go. All right, let me zoom you out. All right, the fun's going to stop here in the fun room for right now because I've got to get into the other room there and start setting up what's in your box toolbox giveaway, which is the big event this time of year, and it's going to take me several days to get it set up. I had to come out here this morning and I had to play with it because it was just late yesterday. The technical rep from Op Lasers helped me discover that my X-Carve was asking for a much higher rate, input rate for the current on the laser, and I adjusted that, and then I started getting some performance out of the laser. And so we did two of their logos, and then I took my logos, created the bitmap figure for that, brought it into their software, created a G code, put it into easel, and then you saw us cut it out right here. This is white birch 1/8 plywood, and I'm looking forward to other materials, brass and aluminum, stainless, and painted surfaces, and all the variables that you can use the laser on. Op laser little logo right here was 2 passes, and it actually started showing us depth. So we also know that there'll be some items that we'll actually be able to cut through, and the limitations and all of that we'll kind of be playing with as well. This logos that I printed out here right now, and also the Op laser cut out there, was about 50% of the power that this laser has by the settings, the amount that I told it to go. So I thank Op Laser once again for introducing me to the laser, and this is just a start. So there's a lot more to come. All right, before we go, I want to remind everybody that I have a couple days left on my t-shirt campaign at TeeBlaster, and this is one of the shirts that I ran last year, and this is the same shirt running, same shirt print we're running again. The tethered flag. I've had a lot of requests for this logo here, and I'm running walk to talk on the pocket area of the t-shirt. There's pocket tees, long sleeve tees, and now zipper hoodies with that logo and artwork on it. You can get them in blue, black, and white. All right, TeeBlaster.com. Here's the link for the campaign. All right, and here's the link for Op Laser. Until next time, get her done.